Okay, now let's look at the other two adjustable errors. That is the errors which we can adjust by using these two adjustments here. Those errors are both adjustments to be made on the horizon glass. Now the first one we did was perpendicularity. The next one I want to talk about is side error. And the adjustment for side error is made by turning this screw. Again, if I turn this screw, then the mirror hinges around these two clips, and the effective movement of the mirror by turning that screw, the one closest to the frame, will cause this sort of movement of the mirror. Now, what effect will that have? Well, if you think about it, if you have the light from the body coming to this mirror and reflecting off that mirror, if this mirror is not adjusted properly in terms of this adjustment here, in other words, if it's leaning forward or back, if it's not in fact parallel to the plane of the instrument, 90 degrees to the plane of the instrument, then effectively the light coming to your eyes through this telescope or blank sight tube the light will be reflected off to the left or off to your right, which means that when you're looking, for example, if I adjust this instrument on 0 and I have it perfectly on 0, if I look at the body, say I'm looking at the sun, and if I do not have this mirror a nice 90 degrees to the plane of the instrument, then when I'm looking, I will see two suns, one to the left of the other, because one will be the reflected sun and one will be the true sun going straight through the glass. But because this mirror is not perpendicular to this frame, that reflected image of the body of the sun, say, will be to the left or to the right of the true. It will be to one side or the other, and I will therefore have side error. So we need to talk about how we're going to adjust our side error. Well, there's a couple of ways. If we literally use the sun, that does mean that we would have to have these shades in place. At least some of these shades. I find usually we're using the center two of these shades. And we need all of those, which means if I'm going to adjust out side error, well, I'll need to sneak my finger in there, which is doable. And then while I'm looking at the sun, with the instrument set on 0, because I want the true and the reflected ideally on top of each other, so if I'm then looking at the sun, if I see the body to the left or the right of its reflection, so the true and the reflected are side by side, I will turn that screw until they line up and become one. Now, let's look at the final error, and then we'll come back and we'll sort of visit the errors again, in particular what happens if we have more than one error. So let's move the shades out the way. Let's look at the final error, that is to say what we call index error. Index error is possibly the most easiest one of the three to understand. Index error means that this mirror, the horizon or horizon glass, is out in this plane, which is, if you like, the complementary movement of this, which means effectively that the reading is either going to be over-reading or under-reading. So index error, if we have any, is just another way of saying our instrument is not zeroed properly. Now, how do we know we have index error? Well, we start by turning the instrument onto 0, and with the instrument on 0, we then look at, say, the horizon, and the horizon must form a perfectly straight line. If it's not, and if there's a split, we then need to adjust the screw here furthest from the frame on this instrument to effectively rotate this mirror until that horizon appears as a straight unbroken line. Of course, if you look though at this mirror, these two screws, the one that we've just talked about for index error and the previous one for side error, they're somewhat interactive. The mirror sort of floats on both of them. So by adjusting our index error, we might inadvertently put back side error. By adjusting our side error, we might cause some index error. And we may find that we cannot get rid of one error without having the other error. And if that is the case, what we will do is we will favor getting rid of the side error, and then we will simply note what the index error is. In particular, if, for example, I get rid of my side error, and I then find that I look at the horizon and it's a broken line with the instrument on 0, what I can then do is I can say, well, let's say I turn the instrument, the adjustment, and I find that there I've put it on 5 minutes, that's about 5 minutes. It's reading basically 5 minutes. And by doing that, I find that horizon appears as an unbroken line. So to cause the effect of index error to be removed, I'm having the instrument on 5 minutes. That tells me I'm overreading by 5 minutes. It's called having my index error on the arc, that is to say on the positive side on the arc. That means that every reading I obtain by observation, I must initially subtract the 5 minutes because I'm on the arc. If it's on, take it off. But what if it's the other way around? Supposing that would be ideally no index error, so the horizon appears unbroken with the instrument like that, but now I find that's not the case, but in this case I need to turn the drum something like that. Now that says 55 minutes, but that's effectively 5 minutes away from 0 on this side of the arc, known as the arc of excess. I'm reading, if you like, negative 5 minutes. I'm under reading. That is called off the arc. And every time I take a sextant reading, I must add that 5 minutes, in this case, to my reading. So if it's off, put it on. If it's on, put it off. So that's your index error.